Welcome back to the puzzle 11 from the Advent of Code 2017. I make it a copy for puzzle template and replace the puzzle with puzzle 11. I added the puzzle 11 to our project. This. Let's continue to the next one. Hex grid. That's interesting problem. I think this is the solution for our problem. Let's take this. Okay. If I have columns like this, I can have rows like this. So let me take my pen and try to draw on this. Let's see if I can. So my columns will be like that. Let's say 0, 1, 2, and I will have rows, rows like that. So my rows will be 0, 1, 2, 3. So every intersection will be inside of one honeycomb or one hexagon. So this can be represented as a two-dimensional matrix. So every movement can be transposed to a two-dimensional position. Okay, let's do that. So let's start by writing the test, because last time we forgot to do it on the second part of the puzzle from day 10. So let's say we have a get distance of input and string -1. So this will be get distance of sample, and we'll have the following samples. Not really, that will be a 0. This will be a 2. And this will be a 3. We don't need this. Okay, let's make sure that our test is failing. Where is the test output? Duplicate test names. Puzzle 11, sample 1. We didn't switch. What happened here? So the not test southwest, not test south south. Somehow we didn't replace this. So 3023. 3023. Okay. Let's run it again. Check it out. I'm in the middle of the camera. Okay, we have some failing tests. Let's go back to this. Actually, not yet. As usual, we want to have a domain model direction that will be north, northeast, northwest, south, southeast, southwest. 6 directions: north, northeast, northwest, southeast, south, southwest. Okay. And and we want a wave to read those. I can the fast and somehow easy way is to directly take a string and split it by comma, and after that a big match over those values. But I don't like that approach. So because I want to have fun, I will have a parser in a parsec. So my parsers will be something like will be okay, that will take the north and will generate a north direction, and I will have two more northeast, and a northwest, and this will be similar for the south. So okay, so I'll have a parser that will take all those will be separated by and will be a choice of, and if we remember right from a preview episode, we need to have them in a proper order. If we start with north or south, our parsers will fail. So we need to have first northeast, northwest, then north, and similar with the south. Southeast, southwest, and south. And this should be a parser that will take comma and maybe other spaces. Actually, let's have the commas faster result. Let's move it on more lines to be easier to read. So let's read. Actually, I want to do something different this time. I will need a movement from the current position. So I will need to have a position of type of row and column. And I will need to have a function that will take a direction and a position and will return a new position. And let's see if it's not. Now we need to bring up this one. This one. So this will be the column, this will be the row. So if I'm moving in the north direction, then the row this is the row and this is the column. So the row will increase up and the column will remain the same. So I will have a position with row equal position dot row plus 1. If I'm going to north east, I will have a position with like that and okay, northwest, south, southwest. So we want to go to northeast, not this one, this one. Northeast will be a different column and the same row. So the row will remain the same and the column will be a row column plus 1. I'm sorry, position column. On northwest will be the column -1 and row +1. If we are going to south, will be the row -1 in the second column. If we are going to southeast, will be the row -1 and the column +1. And if we are going to southwest, will be the same row, but the column -1. And let's check now. I wrote those indented like this by intention, because I should have a symmetry. So +1 +1, -1 -1, plus minus plus minus. I have a symmetry. Okay. And what I wanted to do is, instead of parsing a direction, I can parse directly a movement. So here I can partially apply the direction to the movement. Move in direction. Actually, let's do like this. Okay. And now I have a list of movement functions. So let's put it movement of input equal match run the direction on input with a success of result, and that will be our kind of success. We choose there is a success of result, and if it's a failure, reason, and the other arguments, the state and the position, I think, the other arguments will be a fail of reason. Okay. So our code will be something like parsers read movements of input, and this will return a choice. So choice map will give me a list of movements, and with that list of movements I need to visit each movement and get a final position. So will be list.fold and this will receive a function that has a position and a movement, and will go to move from the position that will return a new position and an initial state. My initial state will be the row 0 and column 0. I need to add an open FSharp here. So right now I have a choice with a final position, and I need to see how far is that position from the initial position. So let's look again at the picture. Actually, I will prefer it without. So from this point, if I can go like this or direct like this. And if I'm trying to get from this point to this point, I will have to go like that or like that. So I need to figure out what is the distance. So my distance to the north will be the delta. To the south will be the delta. To the north east will be the delta. To the southeast will be the delta. On each of those directions. But my distance to this point on diagonal, so will be the quadrant 2 and 4 will be 1 and not the sum of those edges, but on quadrants 1 and 3 my diagonal distance will be actually the sum of the edges. So I will have different behavior. In the quadrant 1 and 3, I will have to make the sum for the delta on the row and the column, and on the quadrant 2 and 4, I will have to take just one of those edges. And what it remains? What is the displacement on the other edge? Yeah, let's try to implement this. So get distance position will be what? Match not row. If I need to see if it's in quadrant what? So if it's in quadrant 1 or 3. So greater than 0 and position dot column is greater than 0. Actually, I want first to check with 0. Will be a direct thing to do. Wait. So I have true and whatever else, I don't care. That means that the final position is on the same row. So the displacement will be the column, the delta of the column. So the displacement will be, let's type it like absolute. Otherwise, if this is false, actually I will reduce the noise, and this is true, the column position will be in 0. I will have the same but for the row. So if my column is 0, my displacement will be how many cells on the row on each side. And otherwise, that means both of them are false. I need to verify the quadrant. Row greater than 0, not column greater than 0. Let's see. So if both of them are true, so will be something like this. So will be the quadrant 1. Then I will have the common the minimal part summed, then the displacement on the delta from the minimal for the row or the column. So the logic is, let's assume this will be the 0 and 0, and I have a displacement of let's say 2 on the column and 3 on the row. That means a position like 1, 2, 1, 2, 3, a position like here somewhere. And to reach that position, I first need to reach this position. And this position will be the sum of the edges. So this thing plus this thing will give me here, because can be interpreted as this plus this will get me here, and this plus this will get me here. And what is remaining will be the delta between the row position minus minimum from those two, and row will be the maximum. So I need to write those as, so if it's true and true, I need, come on, minimum will be min of position row and position column, and the maximum will be the max of position row and position column. And my displacement will be, as I said, 2 times the minimum so times the minimum plus the maximum minus minimum. So will be actually the minimum plus maximum. Let's see. The same logic applies in symmetry with our origin. So the quadrant 1 and quadrant 3 will have a symmetry. So to be in quadrant 3 it will be false and false. Actually, I can have like that. And this will be absolute. Absolute. Actually, already are negative. Both of them for the quadrant 3. No, it's easier to understand at a later time. I don't want to make something harder to read. So this also will be an absolute. Okay. Yeah. So that is the case for quadrant 1 and 3, and I need to have the true false. That means the row will be positive and the column negative. So the row will be positive and the column negative will be the quadrant 2. Actually, I think it's symmetrical. And the other case will be a false and true. And in that case, to reach from this point to this point will be on 1. So it will be actually so from this to this will be the number of steps on a single edge. So going from let's say from this point to this point, first I need to go to this point. So it will be 1, 2. that is the number of steps on the edge, 1, 2, the minimum between those, and the following steps will be the delta between the maximum and the minimum. So I will need again the minimum and the max. And my answer will be the minimum plus the maximum minus minimum. Okay. To be that simple. That's right. So let's continue on the following line. Choice that map of for this displacement, it takes a position and returns an int. Yes, this place 1 from 0. This will be the year distance. Okay. And this then will be this is a parser that can fail if the input data is in invalid format. Then expect success fail to understand the data, the input, and then this should be equal with expected. I ran the test and it was failed. Okay. So no red, I can run the test. Let's see. Come on. Wow. So my assumptions were correct. Then I need to uncomment this, take the input. Wow. The input. Oh, how I was doing. So in input and samples, I create a new file and I will respect the convention for the name. So it's the J11 input, and here I will paste my code. Just one line. I took everything. Okay, on one line, and save that. And this will be the read file, and I need to provide the 11 input, just the stem of the file, and the expected value will be -1. No red, so let's run it. Let's see if I'm still in the camera. Yeah. This is my assumption. Nice. Okay. How many steps away is the furthest he ever got? So we need to run this on every step of the code. So my state will be a position and a maximum distance. Actually, let me write oh, and we'll take a movement, and this will what? Will new position will be movement of the new position, and will be a maximum between max distance and get displacement from 0 from the new position. And the new state will be a new position and new max distance. So I need to provide the folder, and the initial state will have, since our distance will be always a positive number, I can pass -2 without so this will be the implementation for the get maximum distance. A function that will take a position and response. And will return the result. It's a good strategy to not expose tuples. For me, it was easy here to use a tuple instead of creating a new type, a new record. But that thing will is enclosed in this function. I'm not exposing it to the rest of the code. So this implementation will be somehow identical. Actually, let's not corrupt those. Just take them, put them there, and instead of get distances, I get maximum distance. Example. I have test here, no test. Okay. So this can be deleted, and this will be also -1. I need to take this and put it here to fix this test. Okay. Save it. No red. That means I will be able to run it, and we'll see the output for the failing test. Oh, so that child was working. Far distance from his parent, bad parent. Another gold star. So this will conclude the day 11. See you soon.